So the next question we are doing is we are converting a binary tree into a binary search tree. So if we actually take a look at it, so let's say we actually have let's say we have a binary tree. So 1, 2, 3, 4, 5, 6, 7, and this is not a binary search tree. This is a binary tree, and what I want to do is I actually want to convert it into a binary search tree, which is like this. So structure will remain the same. All we have to do is we have to convert this into a binary search tree. And we have written functions for doing all of this in our code. So I think we should be okay with that. So the first thing that we'll do over here is we'll get the size of this, and we'll actually create an integer array which actually store all these values. So our values is 1, 2, 3, 4, 5, 6, and 7. And we can do this in a sorted manner because we can just do an order traversal, and we already have our function which actually does the adds the value in there. So we have this. Next, what we will do is we'll actually take this array, and we'll actually call this function, and then we'll actually do the same thing. We'll get the middle part of it, and then we'll get the value over here, and then actually yeah, so that is what we'll do. We'll do a in order traversal of this one, and then we'll pass an integer pointer. So the integer pointer will actually start with this value, and then it will do an in order traversal. So from 4 it'll go to 2, 2 it'll go to 1, and then once it reaches over here, it will actually put the array value of the pointer, which is 1, over here. Then it will go to the next one, which is 2, so it'll put the value 2 over here, and so on and so forth. Let's actually see how this is going to be working in our code. So let's go over here, and we'll come over here, and we'll say public void convert binary tree to BST. Okay. First thing we'll check is if root is equal to null, we just return. Okay, so if root is null, we just return. Otherwise, why is this complaining? Public void convert up, yeah. So if root is null, it will basically return null. Otherwise, what we'll do is we want to take the tree and then store it inside an array. Right, so we'll call this, we'll first actually get the size of it. So we'll say integer size is equal to size. Okay, so we get the size of this. Next, what we'll do is we'll actually have an integer array, and we'll store the values in the array. Okay, so we'll store all the values from there inside the integer array. Now we have this array, and what we'll do is we'll actually sort this array. So we'll say okay, so our arrays is being sorted. So after sorting this array, what we want to do is we want to call a function. What that function will do is it will basically convert all the, it'll take a node, and it'll take the integer array, and it'll take a pointer, and then it will basically go there and go through this tree, and then it will basically write all the values. So we'll say private convert array to BST, array to BST, and then I don't even think we actually need to go in the middle and stuff. We just need node and integer array, and we need int store PTR, because we want the PTR to always keep increasing. And this will actually return us, should it return a node? No, void, I think void should be fine. So this is the void which is there, and we will call this function. So we'll say array to BST, and node that we'll pass will be root, and integer array is arr, and the pointer. So we actually need to create a pointer. So we will say int store ptr is equal to new int store, and the value will be 0. Okay, so the value is 0, and we are sending ptr over here. Okay, so this is good. Okay, so that is good. Over here, this is just a simple in-order traversal. So we'll say if node is not equal to null, what we are going to do is in order. So we'll go to the left first. So we'll say this, and then node dot left arr and ptr, and then we'll do something, and then we'll say array to BST node dot write comma arr comma ptr. Okay, so we have to figure out what we are doing in the middle. So in the middle, what we are going to do is we'll say node dot data is equal to arr of ptr dot value. Okay, so we get that, and then we increment the value of the ptr. So ptr dot value plus plus, and I think this should basically do it. So I think this should do it. So convert tree to BST. Okay, so that is good. Let's actually create a init function. So private void this will create this tree, the 1 2 3 1. So we'll say node is equal to root is equal to new node, and node is 1. Okay, so we create 1, and then we'll say root dot left will be equal to, we'll create the second level. So root dot left would be equal to new node, and value is 2, and root dot right is equal to new node, and the value should be 3. Okay, so we have the left, we have the right. Second level is done. We need to go to the third level. So we'll say root dot left is equal to new node, and this node is 4, and then root dot left dot right is equal to new node, and the node is 5. Okay, so we have this, and then we'll actually have the right. So this should be equal to 6 and 7. Okay, so we'll initialize our tree. So this will create the tree, which is this one. So we'll come to the main, and then what we'll do is we'll comment all of this, and then we'll say so initializing would actually do that, and then we'll say bst dot level order. This will do the level order for the BST, so it should print 1, and then 2 and 3, and then 4 5 6 7. Then what we'll do is, after converting, it should have the root as 4, and then the second level as 2 and 6, and the third level should be 1 3 5 and 7. Okay, so we'll do bst dot what was the function that we created? The function that we created was public void convert binary tree to BST. Convert binary tree to BST. Okay, so that is our binary tree to BST, and then we'll say BST dot level order, and this should print our thing. So let's run this. Exited without BST is equal to new BST dot level order. It did not do anything. Huh. Okay. So we have a BST. Come over here. We initialize the BST. Oh, root is equal to. Okay. Now it'll work. So run the main. Okay. So now it is running. So the first one, it has 1 and then 2 and 3 and 4, 5, 6, 7. Then it is 4, 2 and 6, 1, 3, 5 and 7. Okay, so that works. We'll come back for our next video.